We see the objects around us. We see the objects around us. When we enter a dark room, we cannot see anything. On switching off the light, we can see the objects inside the room. So, this indicates that light is required for observing the objects. For seeing the objects, light is required. During daytime, we see the objects due to sunlight. Due to sunlight, we are able to see during daytime. And this is the source of light during daytime. During night time, we use electric bulbs, torch lights, candle lights, etc. to produce the light. To produce the light, we use such devices. They are called the sources of light. So we can see objects. We can see objects when there is light. When there is light. Without the help of light, we cannot see anything. How do we see the objects? How do we see the objects? Let us consider the objects we see during daytime, like a tree. The sunlight falls on the tree and it will be scattered by the tree. The scattered light enters the eye and thereby the sensation of seeing, the sensation of vision is created by the light entering the eye. So, the light is emitted by the source, that is sun. It is scattered by the object and the scattered light enters the eye and this light enables us to see the object. This is how we observe the objects. We see the objects around us. We know that light is scattered by some objects. So they abstract light, and some objects will enable the light to pass through them. They are called transparent substances or transparent medium. In some substances, light will be transmitted partially. They are translucent substances. So substances are divided into opaque, transparent and translucent. Opaque substances, they do not allow the light to pass through them. Transparent substances allow the light to pass through them, and translucent substances, they allow the light partially. They allow the light partially to pass through them. There are several wonderful phenomena which can be explained using the properties of light. Using the phenomenon of light, using the properties of light, we can explain several phenomena like image formation in a plane mirror, image formation in mirrors, and twinkling of light, formation of rainbow, etc. Such phenomena, and also the refraction of light or bending of light when it travels through some media. We can explain such phenomena using the properties of light. By observing the optical phenomena around us, like sharp shadows formed by objects, we conclude that light travels along straight lines. By the observation of the sharp shadows, we can conclude that light travels along straight lines. To study such straight line motion, this is also known as rectilinear motion of light. Rectilinear motion of light. We study such rectilinear motion by imagining a ray of light. Light is considered as though it is composed of rays to study the rectilinear motion of light. There are some phenomena which cannot be explained basing on rectilinear propagation of light. We can explain such phenomena by treating bending of light, and this is explained under the phenomenon diffraction. Under the phenomenon diffraction. There are some other phenomena which can be explained by treating light as particles, like photoelectric effect. We can explain Photoelectric effect by treating light as though it is composed of particles, and these particles will travel as streams of particles. Light is considered as though it is traveling as streams of particles, and this is particle nature of light. We can explain diffraction by treating light as a wave. We can explain diffraction and polarization by treating light as a wave, but we cannot explain photoelectric effect by treating light as a wave. We treat light as though it is composed of particles to explain such phenomena. In 10th class, we are going to study the reflection of light by spherical mirrors and also refraction and the natural phenomena that can be explained using reflection and refraction. In 10th class, we study reflection and refraction in spherical mirrors and refraction in lenses and their applications. We have already studied the reflection in plane mirrors. The properties of the image are the image is virtual and erect. There is lateral inversion in the image, and the size of the image will be equal to the size of the object. The size of the image will be equal to the size of the object. The distance of the image from the mirror will be equal to the distance of the object in front of the mirror. These are the properties of images in plane mirror. Real and virtual images. Real images can be caught on a screen. And the virtual images cannot be caught on a screen. In cinema, we notice a real image. The image is formed on the screen. In a plane mirror, the image is virtual. We can see the image and we cannot catch it on a screen. So, images are real and virtual. If the image can be caught on a screen, it is a real image. If it cannot be caught on a screen, it is known as virtual image. Laws of reflection are valid in all cases. They are valid not only in plane mirrors, they are also valid in spherical mirrors. Whatever may be the type of mirror we choose, laws of reflection are valid. So, laws of reflection are valid in all cases, in all shapes of mirrors that reflect the light. Curved mirrors. If you take a spoon, one surface is curved in, the other surface is curved out. The surface which is curved out is called convex surface. Convex is curved out surface. The other surface is curved in. It is called concave surface. Whenever we consider a curved surface, whenever we consider a curved mirror, it will have a convex surface and a concave surface. The curved in portion is concave and curved out portion is convex. Concave and convex mirrors. If the concave surface is polished and the convex surface is painted, if the concave surface is polished and a paint is applied to the convex surface, then it is called a concave mirror. So, if the reflecting surface is concave, it is called concave mirror. If the reflecting surface is convex, it is called convex mirror. To prepare a convex mirror, we apply a paint to the concave surface and the convex surface will be polished. The polished surface is convex, so it is called convex mirror. Like this, we prepare convex and concave mirrors. We make convex and concave mirrors. Generally we come across spherical mirrors and paraboidal mirrors. Spherical mirrors and paraboidal mirrors. Spherical mirrors. A spherical mirror is the part of a spherical surface. A spherical mirror is part of a spherical surface. So it is called a spherical mirror. We have two types of spherical mirrors, concave mirror and convex mirror. For concave mirror, the concave side is polished. The concave side is reflecting surface, so it is polished surface. For convex mirror, the convex surface is polished, so it is convex surface and convex mirror. To study spherical mirrors, we use some terms. We consider certain points, distances and lines. We name them appropriately, like pole of the mirror, center of curvature, focus, pole of the mirror, center of curvature, focus, radius of curvature, focal length, principal axis, aperture of the mirror, etc. These are the terms that we are going to use in the study of mirrors.